So I guess I should start now. I'd like to welcome you all to my talk called Architecting Content for a Live Service Game. To start off, I'd like to introduce myself. My name is Joachim Melander, and I am a senior game engineer here at Jaeger. I have worked for Jaeger almost for 6 years, and during my time here, I have exclusively used Unreal Engine 4 on 3 game titles, predominantly Dawn 2, Dreadnought, and then our latest game, which we're currently developing here at Jaeger, called The Cycle, which is getting released later this year on the Epic Games Store. Now, my title of my talk is called Architecting Content for a Live Service Game, and that takes quite a long time to say. So I'd like to just, during my introduction, basically go word by word, so I don't have to say this title a lot more times. So to start off, I'd like to talk about content. Content, from my own opinion, is the definition about what your game actually is all about. It is the explosions that exist in your game. It's the gadgets your players will use in your game to basically interact with the world you've done. It's the amazing buttons your players will be able to do to set all the cool settings in their game. It is the story in general you're trying to tell, and it's the universe your players, to a large extent, will be immersed in. Now, I'm a programmer, so I predominantly do not sit in Maya and model, nor write long narrative text in general about what the game is supposed to be. But I very much affect all these different parts, because to a large extent, I define the architecture to a lot of aspects about how this content in a large aspect will be represented. Because I define how many of these contents will actually be represented in the game. I define how varied that content indomitably will be. I define to what quality it will be represented in the game, and the most important part for production, when the game will actually, of that content will be released. Now, if this would be everything I'd be talking about, my title of my talk would be primarily just architecting content. But there's a last part of this, which is for live service game. And that, by its own margin, makes the architecture you have of your content even harder, because you are not only releasing your game once, you're releasing your game over and over and over again, and not only releasing stuff in a DLC, which adds new content, you're modifying your content over and over and over again very frequently. And that's exactly what my talk will be predominantly be about. It will be a story about Jaeger, over our 5 years development time of Dreadnought, which was our first live game here. I will talk about how original architecture that we set up for our content when we were not live, then all the problems we had with that given architecture when we actually were live, and how we solved them while we were actually consistently releasing patches and updates to our game. And then something that not a lot of live game developers actually has the opportunity to do. We got the opportunity to work on a second live game, and how we took a lot of those lessons, how we changed a lot of parts about how our architecture was set up into our new game called The Cycle. So let's talk about Dreadnought. Now, Dreadnought is a game where you control one big giant spaceship, and you fight against other people who control big giant spaceships. The content is pretty simple. It's ships, it is weapons you put on ships, it is abilities you put on ships, and it's in general a lot of vanity and a lot of customization options to make your ships look really awesome. So a lot of aspects, it's ships and a lot of stuff you put on ships. How that content to a large extent is architectured is pretty simple. It follows a lot of basic rules about how I would imagine a lot of Unreal Engine 4 applications are architectured. You have a native code class. In this case, this would be our ability class. And then you would derive a blueprint from that, something like AB ability BP. There you would be able to set all the fantastic properties and tuning variables that you would want to have. And furthermore, you would be able to override specific code functionalities where you could provide whatever cool things you wanted your specific ability to do. And this was, to a large extent, our original basic architecture we had of our content on Dreadnought. Now, we're a live game service, and it's important to note that content architecture, it will not only be about the front end. When you're inside the menu, you're not connected to a dedicated server, but you're still doing, for instance, in our game, a lot of customization and purchasing options. And these ones, you would like to stay persistent, because you would not want to recustomize your ship, nor force you to buy new content every time you log into the game. How you usually solve this is you have something called a backend application, which basically runs persistent across the lifetime of how your game will be. And you have to basically communicate in the menu with your client over to how this backend is. Now, one of the challenges you will have with your content architecture and the way we set it up is that usually your backend will not be an Unreal Engine 4 application, but we have all these blueprints, and we need to reflect this somehow over to the backend. What you're then going to have to do is you're going to provide some kind of data reflection over how these different content pieces are set up individually to the backend. And the first thing you have to do is to provide some kind of UID over to this content. Just rely on an asset path or something like that will not be deterministic, because once a user, for instance, have purchased one of these content pieces, it needs to stay persistent forever and ever and ever. So what we did is, in general, as you can probably see, every single content piece that needed to be reflected on the backend, we gave it a UID. And then once you had submitted something, like a content person had submitted some stuff, we ran a commandlet on every snapshot. What it would do is, like, if you don't know what a commandlet is, it's basically like what a cook or what a localization service is. We coded our own commandlet, which will literally take all the content that would be relevant for the internal backend, and then it will basically output something in a text format in a JSON. And that text format by its own margin can be loaded on client and the backend, meaning that you have from their end basically built the communication protocol that your client needs to communicate with your backend services. And this is to a large extent how our content architecture were on Dreadnought when we shipped closed alpha. We had all our content created. We had our architecture set up in regards for this native code class and derived blueprint. And then on top of it, we had this UID association and in general set up with our protocol with our backend. And then we started facing some problems. And that, to a large extent, goes to the second part of this talk, where I'll start talking about problems and solutions that we started having with this given architecture. What I wanted to say, though, before I really start digging into the problems, is that all of these problems we had to fix were while the game was inevitably live. That is very difficult and very harder to do because we need to maintain stability while we're consistently developing new and new updates to retain and keep our users going. That means to some extent we can't do the best solution, we simply just have to do the solution that actually somewhat makes us be able to ship it in 2 weeks and do incremental and better updates on and on and on. The first problem we started having was in regards for scaling content. Because in general, scaling content is something you will always have to deal with when it comes to a live game service, because your content is going to consistently increase and increase and increase. If you're interested in what we had on Dreadnought when we originally shipped our closed alpha, this was around the amount of content we had. We had 135 abilities, 15 ships, 30 secondary weapons, and around 150 vanity items. After 1 year and 1 year and a half, actually, our content amount increased up to this: 700 abilities, 55 ships, 165 secondary weapons, and a whopping 1,173 vanity items. If you'd like to see the percentage, you can see them here. But in general, you can just see that, especially after you ship live, the amount of content you will have will just increase like crazy. And the way we were originally managing this content in runtime was not really that great. We were actually loading all this content at startup. And while certainly this was actually not causing that much problem to begin with, we started seeing some problems in regards for loading, iteration times, and memory in general. I will now show you some of the worst numbers, but remember, they're the worst ones. We did resolve them to become a little bit better later. But our game startup time went all the way from 14 seconds all the way up to 1 minute and 30 seconds. Our editor startup times for our developers went all the way from 1 minute, 13 seconds up to 4 minutes and 22 seconds. And we also wanted to ship on a lot of different platforms, and we were consistently going out of memory, causing huge problems for us to always be able to deliver patches on all the different platforms we wanted to release on. So this was, to a large extent, causing problems, and we needed to somehow resolve these. And you guys could imagine that that is how we then started refactoring how our management of our resources were, where we started introducing something called soft referencing, where all these resources won't be loaded in the beginning of the game. And once we actually required those resources, we would asynchronously load these things to be able to exist when you wanted to have them. Now, anyone that has ever implemented asynchronous loading in Unreal probably knows of the pattern that exists, where indomitably, if you're trying to async load a lot of things, and then you have one individual load, which is called a static load in the engine, where you're trying to get that immediate asset at the exact frame of execution, it will flush all the current asynchronous loads and force all of those ones to also be loaded on the same frame. On a lot of aspects, you'll probably see around 5 to 10 seconds hitches. This means that the way you have to set up your references and loading of your resources in your game, you need to really define the different places, because you can't combine these two things at all. And this is what we did. A lot of times it's like when it's a loading screen, you can do static loads. When it's not a loading screen, you do async loads. So we refactored away all of these things, but it's super important to note that we're a live game, so we have to release multiple times over, and we want to release very often. And what that indomitably means is we need to make sure for every single new feature update, we're not breaking the specific patterns that we have set up. That meant that we were running constantly AI bots overnight for every single branch that existed in our internal game. And if they would ever invalidate this, we would dump the call stack, we would dump the logs, and in general, make sure that we were able to release on the given time we wanted to do. On top of it, we wanted to do async loading while connected to a dedicated server. And by default, how the engine behaves, if an actor becomes relevant that is part of an asset that has not been loaded yet on the client, it will force a static load that will immediately load it on one frame, invalidating, again, all the individual async load you have. But just enabling this given option will just make it async loaded, and then everything else will work inherently from there. But this is to a large extent what we implemented, and this, for our end, solved a lot on the scaling content problem. The second problem we started having in regards for our live game maintenance on Dreadnought was in regards for creating content. Now, as you add more and more features to your live game, you're going to start facing the problems of that your content creation is starting to get more complex. What we were able to do always when we were shipping closed alpha is we could very easily define all the properties and everything that went into an individual content in the nice edit defaults view here. However, a little bit after we shipped closed alpha, we decided to change our progression system, where we started adding all these big tech trees, where you needed to unlock all the items that were existing in our game. That meant that, for instance, if you needed to unlock this item, what you needed to do is you actually needed to unlock these items before. But this meant that the items themselves actually needed to have references to each other, and on top of it, we needed to define stuff like position in this tech tree and the different lines that was connected to them. Trying to express this specifically in this edit default view would be probably pretty hard. Like, it probably looked something like this, but in general, it would be really, really hard to maintain. So a lot of times, what you're going to have to do once basically content creation becomes more complex is you're going to have to start creating tools to basically manage this. Now, the tools that we predominantly did to do this were non-Unreal Engine 4 based. But what was super cool was, as we were already reflecting all this data over to the backend, we could just pipe in that data and then read it from there. So if you look at this big tech tree we had, you can look at this tool, which was generally called our tech tree tool, which was where we predominantly built all these individual items, all these different trees, where all the items you could potentially add to a tech tree would be over here to the right, and then you would basically be able to drag those over and then create these different dependencies and nodes and requirements all themselves together. Once you save this individual file, it will create this beautiful JSON file, which will be really, really long, which could, again, be loaded both on the backend and client and be able to visualize what your tree individually was. And all this stuff is cool, but what this stuff added, though, also that's very important to note, is that we started now adding multiple steps in regards for how your item creation of how your items were. Because not only did you need to create your new unique content in the engine, you also needed to wait for the snapshot to finish to be able to serialize all this new backend data that you had. And now we added this new progression tool. You also needed to open up all your content to actually be able to show it in the game. This led to, in the last part of our documentation, all the way to 142 steps to just create one individual content piece. And what usually happens when you're trying to work on a patch and the designer is working on a patch is that they're not only creating one content, they're creating 20. And imagining going through 142 steps for 20 content pieces, that takes a very, very long time. We did improve our tools, and in general, we worked on these things over and over and over again, but it's always going to be an iterative process, and it's always important when you add new features that you also make the content creation of your live game service be as easy as possible. The second problem we had in regards for creating content for our live service game was, in general, how do we add more variety? Because we had 700 abilities, what is our 700th ability? The way we tried expressing that was through tiers, where in general, as you progress further through our progression system, you unlocked higher tier ships, which would be increasing in power and give you basically a sense of progression in the game. The way we express this is, again, through further inheritance, where you would have this one, and then you would have a tier 3 ability, and then you will have a tier 4 ability. And this worked great to provide different tuning. However, when players were progressing through these different tiers, they were, of course, asking themselves, how can I provide more gameplay variety? And I'd like to give a little bit more of maybe a more bigger example where you can see our ability system, where we had an ability warp, an ability pulse. And now a designer can very rationally think that, hey, we built the functionality for warp, and we built this functionality for pulse. I guess we could also create a warp pulse combining both of these individual elements. That doesn't work. This is predominantly because actually what we have, like multiple inheritance here obviously doesn't work. Like it's just not functionality here. Of course, we could create an additional nested inheritance tree to basically build these things, but we already have 700 abilities. So to a large extent, reuse through inheritance methods like these were hard. What we refactored our system to be was to be more composite, and this was one of the lessons we learned a lot from Dreadnought development in general about how to set up our content architecture, where you want to keep the base inheritance level pretty flat. And then we were working with more composite methods, where we would, for instance, create something called ability actions, which they contained the different executions about how your internal ability would be. We started working on this, but we didn't really finish it all up. But in general, try thinking in this way, where you're kind of trying to build more in regards for reuse, in regards for your architecture and code. But this, to a large extent, was how we were working with the second problem. The third problem that every single live service game will also have will be about releasing that individual content. Because for a live game, you have to not release multiple times over, and it will not act like a DLC where you're just adding new content. You're modifying your existing content over and over and over again. And the speed that you can actually release that content will be, to a large extent, the actual success to what your live game service will be. To be able to express that, we introduced something called branching, which you probably heard from Ben Marsh last talk yesterday, where he went through the Fortnite one. I'll do my best explaining how we set it up also. Because how we in generally worked when we were a live game was that we had different teams working in different branches, developing new features for a new patch. So you would, for instance, have one team working in the development of free branch, and they would be assigned a given feature. Once they were done enough with how their feature were developed, they would merge all those things over to the main dev. Now, they would not be the only development team. As mentioned before, you would have multiple developers all pushing their new stuff over to the main dev. Once enough changes had been accumulated, we would take all those changes, we move them over to release branch, bug fix that up, and in the end, we will be able to release this fantastic patch 1.1. Now, it's important to note in regard for branching is that you're not only pushing, you're also pulling. So once, for instance, Dev of Free branch have been able to finish up their individual features, of course, the other development branches will be pushing this individual content over, making them also be able to have the latest state about what, in generally, the development across the teams were. So then you could imagine if we wanted to release a new patch, we would simply, again, allow the different development teams to work on what their features were. In the end, when enough of those things have been accumulating, we will push that over to a release branch, and then we will be able to have patch 1.2, right? Not really. The thing is, it's super important to note in regards for your content architecture, how you set up that to individually be able to work with multiple branches, because this is something you're gonna need to have a lot of times when you're working on live games. And as mentioned before, blueprints are not mergeable. Meaning that if you would like to merge content from one to the other and they're based on blueprints, you will simply have to accept like the state from one branch or the other. You can't combine the changes that have happened across two different branches. And certainly you can think about how to set up your production workflows to be able to have different development teams working on other things. But for every single release we tried having, we always had a lot of conflicts. And on that level, you predominantly then have to just ask your question, who did the most work? What is the most complex thing to just redo again? The specific situation I gave here with 4 development branches and just the release branch was just a very much more simplified version about how our branch setup was up. I want to excuse the programming work on the next one, programming art, but in general, I think this to a large extent shows how our branch setup was on Dreadnought. In general, though, I made it a little bit easier. It was 28 branches. With different purpose and set up in a different way to work with people that were both in the United States, Europe, and Asia. Now, if you remember when I was talking about original content architecture, is that content architecture is not only about your front end. We have this fantastic UID, right, that needs to stay persistent. Well, the thing is, we had some bugs, and in general, you could imagine that if you have some problems where this UID would switch somewhere or somewhere else, trying to fix somewhere on the right side a bug where the UID have changed to the left side can be really, really difficult and hard. And we spent a lot of times in general just trying to fix where this UID and where these contents in general had some problems. How in general we fixed this was we initiated basically a database which will in general manage UID creation. Previously we were relying on a Perforce file that would be globally across all branches, but that has some inherent problems in regards to how Perforce is managing it. So in general we were communicating with a database every time we were creating a content. Every time we were merging over from one branch to another, we had a huge set of automation test suites, plus check that UID creation were always great. Furthermore, we created a lot of tools where if someone started working on a blueprint in one branch, they would check it out across a lot of the other branches that existed in the game. And then only the time where it would actually be merged over to their given branch, it would be unlocked again, making it impossible for these people to create overrides. But to a large extent, we also tried our best to basically separate features in different development teams and introduce a lot of production processes in regards to communication across these branches to make sure we were really working well in our game. These were, to a large extent, the 3 different problems we had on Dreadnought in regards for our content architecture. And even though I probably have been quite negative under the different Dreadnought development we had during live, we did release 14 different patches consisting of a massive change in regards to our progression system, a release on our PS4, scaling up from 5v5 to 8v8 on all our game modes, and a lot more. So in general, even though you will have problems, and you will always have problems in live games, it's important to just keep a positive attitude and work your ass off. So we finished Dreadnought, but we had the opportunity to actually work on our second live game, and that was really cool. Now, our second live game was called The Cycle, and we wanted to do a better job than the one we did originally in regards for how our content architecture was set up. Now, you remember what I was talking originally in regards to the content creation side, in regards for how our inheritance setup was with our content. And then I basically showed a little bit about what we did to resolve some of that. Well, we wanted to do something better, because from my end, these things still have a lot of internal problems. First of all, you still need this big back-end data propagation when you need to wait for your internal data to be reflected. And furthermore, none of this content will still be mergeable, making it much harder still to be able to release all the content. So what we did is we started basically taking a step back and thinking about what actually was really cool about this architecture. You were able to define all these different properties through the awesome tools that Unreal Engine provides you in regards for assigning properties and tuning parameters and all that stuff. And on top of it, you have a really cool visual scripting tool that people that don't know C++ can actually be able to affect what your individual content to do. From my opinion, these 2 things are very separate. They're data and execution. And if there's one thing that we did for a change in our content architecture on The Cycle, our second live game, to our first one, was that we separated these 2. And we are defining these 2 things completely separately from each other. This meant that our internal data structure are now no longer defined in the internal content for the blueprint. We're defining them in a struct that is then later reflected in these internal data table rows. We consider all this data static, which means that it will not change during any time during runtime. It will predominantly be there in the beginning, exactly like the default view in the blueprints exist. This would be our items, our UID, that would be existing on the back end and be the main point in regards for back-end and client communication in regards for talking about what items they were. And you cannot have 2 same rows in a data table. Our execution was, to a large extent, the same. We were using blueprints. Once they got initialized by the static data table rows, they were able to store runtime states, such as what is my current ammo count or what is my recall. They would just not simply define what their max ammo were. So if we basically take the step back, this is to a large extent our architecture. We had our data, which has now been changed to these data tables, but our execution stays very much the same. And I'd like to go through the 3 problems I explained on Dreadnought, and in general, how these 3 problems actually got solved by using this. So the first one comes in regard for scaling content, and if you guys remember, it's in general how your architecture is dealing with larger increasing amount of content. Well, now most of our content is actually defined directly in this data table. And what we started doing was to have 2 different ways of actually loading this content. Because from our end, there's 2 different kinds of content. You have your simple data, which is your bools, your ints, your float. And then you have your more complex data, which is your material, your physics asset, your SK. Well, what we do is we load all data tables on startup, but we are weak asset referencing all the complex data, meaning that all our floats and bools and ints exist in the beginning. They don't have to be loaded together with some complex data. And then when we're actually trying to do something in the game, that specific execution will be the one responsible of actually asynchronously loading the content that is inherently there. That means that if you would like to visualize a UI icon, you pull the UI textures that inevitably be existing in that data table row there. If you like to do a more complex calculation into our game, you pull the individual data that's required for there. However, you do not pull the UI texture if you're trying to shoot projectiles, nor the other one opposite from there. These different execution steps are responsible of the loading of these resources, and they're also responsible in regards for the lifetime. So in general, what we have done a lot now is we have been much more scalable based on how our execution is, like what the player actually will see, compared to what the other arbitrary data that will be there. Furthermore, I go a little bit on a tangent, but we started seeing a lot of good runtime performance gain here also, because as we were separating data from execution, we started being able to write way more data-oriented programming code here. Because while certainly I was showing this example, where you had your internal data and then you had some blueprints, which would probably operate on a per-object basis, it certainly allowed us to write way more batched executions, and in general have a much more multi-threaded basis about how our internal architecture was set up, giving us much better cache performance and way more better oriented way here. Furthermore, what I think is also important is our asset counts to a large extent got way reduced, much improving our internal cooking times just on the basis that there's much less content to actually be loaded, because most of the content is actually just in this one big data table. The second problem we had was in regards to creating content. And what is really cool about creating content now is that content, creating data and executions are now completely separated. And even though we at Jaeger have worked with Unreal Engine for, I think, now 15 years, we still, of course, hire a lot of new people. And teaching them to press a plus in a data table row and assign their properties, compared to creating this blueprint and then inherit it from this specific class and so on and so forth, is much more complicated for them. Meaning that they can just create new items without requiring almost no actual help to be able to start working. Furthermore, we can very easily add execution to existing data. If we wanted to have our dream about creating our warp pulse, we simply have to say that this data also deals 900 warp pulse damage, and then that's going to be what the execution is also going to apply. The third thing, which is very important for our end, is that this data that you have in your data table can actually be reflected everywhere. Because what's cool about data tables is they can be immediately exported into these JSON files. And these JSON files can then be loaded on the backend very easily in a backend service, having a one-to-one connection between what the client and the server inevitably are working with, meaning that the backend and server are working with the exact same data. And that's really, really awesome. This would also include all our different tools and so on and so forth. So to a large extent, we have improved the workflow about how we communicate with the backend on a much more better level. Something we also found out, which was really cool, is that our data can also now be updated everywhere. And this works in vanilla Unreal Engine 4, where if you have the data table editor open and you press play in Pi, and then you start editing the properties that exist on top there, you will automatically see it reflected in the game, which means that you have implemented runtime property editing with not a single line of engine change, which is really cool. I'll also go a little bit on a tangent here, but if you remember the question I had in regards for how do you create variety of your content. Well, what's really cool with this data-driven approach is that you can actually section off what your individual execution would be. And to give you an example of this, I'd like to give you an example of our weapon system. So if you think about how a normal weapon system is you have a lot of different steps about what that different execution is. You have the initial step where you're actually holding the weapon, which includes what the mesh is, where you're aiming, what the spread, what the recoil you will have in your game. We call this for our self-targeting. Once you actually fire the gun, from my end, you go to the second part of execution, which from our end is called transport. This is the spawning of the projectile. This is, in general, the lifetime of how long this projectile will be traveling, or for instance, a hit scan weapon. Then you have the third thing, where when actually this projectile hits something. And from our end, this is the third step of execution, which means what happens when this projectile hits something. And this we call impact. We actually represent these three things with three different data tables. And what's really cool if you're able to do so is you can very easily swap these things in runtime. I'd like to give you a programming example of me swapping every single weapon in runtime on our weapon system. Like this, basically all the different weapons we have. But as you can see, there's almost no performance impact. There's not a single line of change of C++ code. All I'm simply just doing is taking each individual data table row and just like shooting them on each shot. I'm just swapping them all around, bringing much more modularity in regards for the content that we can create. Now, with this functional execution modular approach, it does not only necessarily need to come from a player. You can actually execute all this data at the same time. Because, for instance, now I'll give you an example here. Here's the turret doing the exact same thing. Meaning, to a large extent, we have now created a very modular executional manner, making both our players, our AIs, and whatever else our game will be able to do, use the exact same kind of function path and the same kind of behavior. And this, to a large extent, is how we are basically reusing a lot of our different implemented systems over and over and over again on the cycle, and hopefully we'll be able to have a live service game for a long time in the future. The third, oh yeah, okay. This is very important to mention, though, because even though I showed that like things got cool, we were able to reuse, this data can be pretty hard to organize. I'd like to just show an example, because now it's to create a weapon. It's not only to click plus on one weapon data table row. It's clicking plus on 6 different data table rows and then linking them all together. This is just an example of the 6 data table row we have that takes up a weapon. We are extending the individual data table editor to basically bring a better workflow inherently in this, but it is a hard problem that we are doing. We're hiring tools engineers, so if you'd like to help on this endeavor, that would be great. The third one I'd like to talk about was the releasing content. And you can probably imagine how the releasing content has become a little bit easier with this data approach, because while certainly our data table editors can't be merged, these data tables can be exported into JSON. And this JSON can be merged across different branches, and then it can be re-imported into the data table assets, allowing us a broader extensibility about what actual content we can do. And to be honest, most of the times when you're releasing games, you're actually predominantly taking the existing features that have been implemented and tuning and iterating them. So what you're primarily having content conflicts are primarily tuning changes, at least this is what we had, and we're no longer having them based on just how our initial approach were. Now, it's important to mention that it's just a reduction amount of conflicts. We're still using a lot of blueprint scripting, and this, of course, is still causing a lot of conflicts, but it's just been reduced way much. Yeah, binary execution. So in general, I hope I've been able to convince you all in how our new architecture, to some extent at least, helps a lot with these internal problems, and how, again, separation of data and execution have helped us create a better game. Because it certainly helped us create a lot of more explosions. It helped us create a lot of more gadgets internally about how our game was. We very much created a lot of buttons. I think we redesigned our menu 3 times. We did hopefully help with this architecture, hopefully helped us create the story we're trying to tell on the cycle, and in general, the universe our players will be into. We actually, Dreadnought was in development for 5 years. The cycle has just been in development for 1 year. And I know this myself because I did the original submit on the cycle, where you're able to aim with your gun and be able to shoot a little bit in February last year. In 6 months afterwards, we had a public alpha test where our players were able to play the game and engage with our given game. Afterwards, we had 5 other alpha tests which our users could be able to have. And in the end, now in a couple of months, we're releasing on the Epic Game Store. I will not say that separation and data and execution were the results to all of this. For a little bit of another thing that actually helped this out, you can join the talk that happens in a couple of minutes in regards to how our backend architecture is. But for everything else, it's the team I generally work with at Jaeger, which amounts to around 60, 70 people in the heart of Berlin. But as ending topic on this talk, my name has been Joachim Molander, and this has been Architecting Content for a Live Service Game. Thank you all.